A lot of major computer manufacturers have announced environmental policies and products in the last 12 months. This has been in response to consumer demand for products that have less impact on the environment. A major factor is how much power electronic devices use. A couple of weeks ago, VIA sent me a VIA PC3500 motherboard. It's the latest in their PC1 staple of boards. VIA asked for my input on building a low-powered system based around this board. Just how low could I get the watts running Windows Vista? One of my first challenges was to find a way to measure the power. I eventually found a device called a kilowatt, designed for 120 volts, which is the standard voltage used in the US and some parts of Asia. Since I'm in Australia, I had to get a transformer to convert the 120 volts to 240 volts. The kilowatt meter can measure volts, amps, watts, hertz, and kilowatts per hour. It allows you to measure any electronic device that gets plugged into mains power. The first thing I want to show you is this mid-range PC. It was built to test Vista and its drivers. During boot up, it reaches around 225 watts. During intense 3D applications, like World of Warcraft, it draws 260 watts. Idle, it fluctuates between 150 and 205 watts. So that's the type of power draw with a standard power supply and mid-range hardware. That includes the appropriate number of fans to keep it cool. How can we reduce this power usage? The VIA PC3500 comes with integrated network, sound, graphics, and CPU. The CPU is embedded on the motherboard. It's a VIA C7D processor, and it draws a maximum of 20 watts. I tested a number of different PSUs. The low-watt PSUs in most cases actually drew more power than other PSUs with more capacity. The wattage labelled on a PSU indicates the maximum amount of wattage it can supply. Just because it says it's 380 watts doesn't mean that it will consume 380 watts. It's only going to consume the power drawn on it from the devices connected to it. All PSUs also waste power through resistors, capacitors, and cooling within their own design. The power supply I chose to use is the Antec EarthWatts. It's more than 80% efficient at 20, 50 and 100% load. It has received the 80+ certification. This particular PSU, compared to every other one I have in my office, reduced the power drawn by the system by up to 20 watts. When building this system, I considered the practicality and price. Laptop hard drives and solid-state drives do suck down less power than SATA or PATA, but they are a lot more expensive, and it means the overall design of the system cannot fit into a normal case. Choosing a mid-level hard drive does save you overall power. The difference between a 7200 RPM SATA drive and a 5400 RPM PATA drive was 6 to 10 watts constant power draw. When it comes to a case to house your low-powered system, get one with as few fans as possible, plenty of natural ventilation, and made of alloy. Alloy is a much better heat conductor than steel. The VIA PC3500 motherboard is a micro ATX form factor. There's a huge variety of budget micro ATX cases. Building a VIA-based sub-60 watt PC is really straightforward. Install the VIA PC3500 motherboard. Optical drive. 3.5-inch 5400 RPM PATA hard drive. An efficient PSU. 1 gig of RAM. Make the cables neat to assist with airflow. Plug in the mouse, keyboard and monitor. And finally the power. I previously installed Vista on this system when I was testing all of the components out of the case. During my tests, the system has had a maximum power spike of 58 watts during boot up. When it's idle, it sits under 40 watts. The CN896 chipset features VIA Chrome 9 HC integrated graphics, which has received the Windows Vista Basic logo. The graphical interface Aero does not run. The Vista Basic GUI runs instead, and Vista is quick, smooth and responsive. Running Windows Vista's performance test, power consumption doesn't go over 50 watts. In fact, the only time during system use that I have seen the system go over 50 watts is when it's playing a DVD. The VIA PC3500 system consumes just 22% the power of this system, which is representative mid-range PCs. If you apply that to a lab of, say, 30 PCs in a school, university, call centre, the cost saving of the energy bills is really quite impressive, not to mention the environmental benefits. With the VIA PC 3500 mainboard, system integrators, NGOs, schools and universities can build cost-effective sub-60 watt PCs. I'm Fiona Gatt from VIA Arena. See you next time.